So now we're going to do the following. I'm going to create a new code block here, and this will test the generalized CNN. And what we have to do first is prepare our data. Basically, all we have to do is we could copy and paste we're only going to copy and paste the train data loader here. And we're going to do something else to it, but let's start off with that. Now remember, we have this thing called myTransforms. What we need to do next is we need a resizing transform. And the way to do that is say rs equals, so rs for resize is a transform where we resize to 256. So this will test 64 by 64 images, and now we're going to create 256 by 256 images that we could test on. And remember, when we created our transforms previously, we used a compose. So we're gonna grab that here. If you've ran all the blocks already, you should already have 2tensor and random rotation. So we'll bring that back down. And after we resize, or after we random rotate our image, we're going to resize it to 256 by 256. Then we could do another train data loader. So what I'm going to call this is batch 64. And all this means is it's a image batch of 64 by 64 images. Copy and paste this, where our batch sizes are now 256 by 256. I don't need to change anything here because it takes in myTransforms, which I've adjusted to include a resize after we've loaded in the 64 by 64 batches. So now what we could do is copy and paste this, but now do 512 by 512, resize the images to 512 for this batch. These are 512 by 512 images. And that's it. Now we have image batches of size 64 by 64, 256 by 256, and 512 by 512. So to test it, to make sure it runs as we intended it to, we're going to say our 64 by 64 CNN is CNN, number of channels, NFM, image size of 64. And we're going to say results equals CNN 64 on batch 64. And what we're going to do is say CNN on 64 by 64 images. We're going to make sure it returns a result. So all I want to say is results dot shape. Now we'll just copy and paste this for the other two. So this 256. So once you've changed everything accordingly so that they're all consistent with each other, we're going to start running all the code blocks. Now hopefully we'll test this and we won't have any errors, but you know how that goes. We do have an error where we forgot to define NC and number of feature maps because it comes up later in another code block. We have it here, but we didn't put it here, which comes before. So let's fix that. Oh, so it has to be a tensor, which means we have to access the relevant information. So we're going to access the A part of the dictionary. I am so sorry. This is what we'll do. We'll say data loader 64, data loader 256, data loader 512. What we have to do next is say batch 64 equals next. We're going to turn data loader into an iterator by DL64. This just makes sure it's consistent and turns into a tensor batch that PyTorch can handle. So I apologize for not checking this beforehand. No, I am not. And this should be good to go now. We have an error here where it says expected to have 1024 channels. And what we did incorrectly here so I made a small mistake. This should have been, so it was -2 earlier. This should be -3 because we have this +1 here. And also what we should do is we'll rerun this, and then we'll also change the batch size to 1 because Google Colab has a limited amount of RAM, and if we kept it at 32, that would have been too much data for us to use on Google Colab. So we'll keep it as it is right now, where batch size is equal to 1, and then we'll just run this again. And then you'll see that we get the expected result. We only have one sample in our batch, so that's what we expected, and then we have a 1 by 1 by 1, which is just a prediction. So, and it worked for all 3 image sizes, which is really good. We only had to use one network to handle all those different images. Imagine if instead of building that network and you wanted to work with 512 by 512 images as well, you had to copy and paste this whole thing and then add more layers. That's just too tedious. So in the grand scheme of things, we would prefer to have this implementation if we're working more professionally, although this one's easier to read out, and for learning purposes this will work out. So choose whatever best fits your situation. But yeah, I hope you enjoyed this tutorial on a smarter way to build neural networks. It's more convenient and it can be applied to many more different cases. In the next video, we'll do an introduction to generative adversarial networks, which we'll be using to synthesize images of gravitational lensing. So I hope to see you in the next one. Peace.